All right, thank you for asking questions. Although you got this far, am I giving you guys too much time to do this? Anyways, I won't renege. So this first question, 7b, says write each mixed radical as an entire radical. So put this back in, basically. It's worth mentioning that negative does not have to go in. Okay, this is a square root. That negative can happily stay outside. So what that equals is that would be the root of, so it's negative, and then the root of 2/3 squared times the root of 5/8. I'm gonna finish and then I'll kind of go backwards. Hopefully it'll make some sense. So it's negative. So this squared, 2 squared is 4, 3 squared is 9, times the root of 5/8. So we multiply those. That equals, excuse me, the root of 4 times 5 is 20. 9 times 8 is 72. Now we simplify that. 20/72 is 10/36. 5/18. So it's negative 5/18. Now, if we had, like, it's not saying that this is simplified version, because I don't know why you would go from 5/18 to 5/8. But imagine you were given this and you were told to kind of simplify. Then you could work backwards from this and go to here. See, now I've got a root. I can take out that root. The root of 4/9 is 2/3. Negative sign is just out there. We're not bringing it in, because if we bring it in, either one, it disappears because it gets squared and taken care of, or it's sitting there, which is imaginary. So we're going to leave that one out. There are going to be times when you bring it in, cube roots and things like that. And I'm wondering if this should be like a video conversation that's posted or something. Does that answer your question? I guess I'll find out shortly, hey? Looks like we're sending telegrams. Okay, let's look at 12b. Not 12b yet, 7c, sorry, 7c. Oh yeah, okay, so 7c is a negative outside of a cube root. Okay, so 7c, negative 2/3, negative 2/3, times the cube root of 2/3. All right, so with the other question, we squared it, right? This one we're going to cube it. And that's why the negative can go in. And that will, I think, I'll answer like the negative cube roots that are allowed and things like that. So we cubed this. So this equals the root of negative 2/3 cubed times the cube root of 2/3. Okay, so this equals, it's going to be negative, because negative times a negative times a negative is negative. 2 cubed is 2 times 2 is 4 times 2 is 8. Be careful, by the way. 2 cubed, a lot of times people go 2 times 2 is 4, 2 times 4 is 6. They're like adding by 2s. You get into this kind of automation. I know I do it lots, so just be careful of it. 3 times 3 is 9, times 3 is 27. As I said before, it doesn't matter where the negative goes. If it's in the middle, top, bottom, doesn't matter. It's all the same. I made way too big of a root sign. Oops, this is cube root, sorry. Cube root, and then cube root, I should have muted that. 2/3, I'll mute it now. Ching. So now we multiply those. Cube root of 8 times 2 is 16. 27 times 3 is 81. So we have negative 16/81. Negative can be on top, can be on the bottom. Let me just check to make sure that I didn't make a mistake. So 7b, negative 5/18, yeah. C is negative 16/81. Yeah, so in the answer, it's got the negative up here. Doesn't matter. Doesn't matter, it's all the same. So if we were working backwards, if we wanted to simplify this, because this one can't be we can't simplify this fraction any further. There's no common factors with 16 and 81. This is even, this is odd. 3 doesn't go into this, goes into here. We can't simplify that. So if we were told to simplify the entire radical, then we could come to this. So you could be given a question like this and say simplify, and then you get this. Take the negative out when you can. So now is now a time to answer why the negative. How did you word the question? Let me just check. Also explain a little more about cube roots. How it's x equals x is an element of reals for all of them. All right. Let's just do it with examples. If I have the cube root of, well, you know what? It's not for all of them. Because if I have like the cube root of negative, well, yeah, it is actually. Yeah, it is. So the cube root of negative 1, that's the cube root of negative 1, negative 1, negative 1, which equals negative 1. If I have the cube root of, say, negative 8, it's the cube root of negative 2 times negative 2 times negative 2, which equals negative 2. So let's talk about variables. If I have, excuse me, the cube root of x cubed, that's what these are, right? That's what these are. So that can just come out. That can be simplified. It doesn't matter whether this is positive or negative. It can come out. I was thinking about this, and I wanted to go somewhere with it, and of course. Oh, I know. Let's say if you have the cube root x to the 4. And so let's say we're told that x equals, wait a minute. See, I don't think that's going to work. Give me 1 second. Yes, it will. Sorry, just remembered. So if we say x equals negative 1, like let's just say we are simplifying this without knowing that x equals negative 1. So this would be x cube root x, right? Because it's x cubed times x, so it comes out. Now, if you're thinking this way, it's like, but wait, there's a negative 1 left in there. But look, when it's to an even power, we know that negative 1 to the power of 4, that equals 1. So the whole answer here would be 1. It does take some thinking. Like I had a hiccup there for a second. Simplifying doesn't mean you have to take it out. Like if you can simplify it right here, do it. If you know what the answer is, if you have to like pull it out like this, then so be it. Does that help? Does that make sense? A little bit? I hope so. Like I said, it might be better to have like a video chat that's shared and recorded because I might not be getting to exactly your concerns. What other question did you want? 12b, which is page 103. It's given us the root of x squared equals plus or minus x. Oh, this kind of relates to what I was just saying about when x equals something. It may not be plus or minus x because it depends on what the value of x is. If we're just solving and we have no idea what x is, we can say that because we know that negative 2 squared equals 4, and we know that 2 squared equals 4. But if we're told x equals 2, we're just told that, then we wouldn't have a negative there. We know that it equals 2. Does that make sense? If we're solving for x, yes. This is just what's possible. But if we're told, let's say you have a question, you're told to simplify, just making something up here. So we all know that's dangerous. And we have 5 root 20 x cubed y to the 3, same thing, z to the 4, where x equals -1, y equals 5, or something like that. I don't want to make it imaginary, so let's say it's -20. So then we plug in these values. We plug in -1 for x, we plug in 5 for y, and then we simplify. That's one of those cases where we know x is negative. We know y is positive. We have no idea what z is. Now, just for funsies, I'm going to finish simplifying this. I said funsies already. So we have -20, times x cubed, so that's going to be -1, and y 5 cubed, 5 times 5 is 25, times 5 is 125, times z to the 4. I should have made z an odd number just to make it more interesting. But anyways, 20, so it's going to be positive here. Here we have a negative times a negative. 20 times 125 is 2,500. Why did I do this? I'll run out of room. $2,500. Is that right? Yeah. So it's 2 times 1250. 2 times 625. 625 is 25 times 25, in case you didn't know. I'm going to do that. 25 times 25, which is 5 times 5, 5 times 5. So we look for the pairs. Taking out a 2, a 5, and another 5. That's Z4. The root of Z4 is Z to the 2. We have the 5 in front, so it's 5 times 2 times 5 times 5. Z to the 2. There's nothing left in the root. So that's 5, so that's 125, so that's 250 Z squared. I have no idea if that's helping, but I'll find out soon, I guess.